What's up, you PHP nutters? Today we're going to be talking about how not to write PHP. Yep, it's Jeff here to berate all the naughty things that developers do that give PHP a bad name. Now, PHP is one of the easiest languages to get started with, and that's due to two major factors. A, it doesn't require strict types, but you probably should get used to strict typing. And B, it doesn't require compiling. So you write your code, you save your code, and boom, you've crashed a server. What do you mean you've never crashed a server? No, nor have I. Number 1, never trust your users. But Jeff, my users are trustworthy. No, that's a slap on the wrist for you, my friend. Listen to Uncle Jeff. You cannot, must not, and will not trust your users. And the code on my screen highlights this very issue, which approximates genuine code posted by a beginner PHP developer. And there are several major concerns staring me in the face, and I don't like it. Now, to fully demonstrate the issues with this script, I've actually replicated a working copy on my Vagrant setup. So I have a web page and I have a database with actual data in it. And you'll see ID1, Joseph Blogs, is loading from ID1 up here and his full name in here. And to prove to you that it is in fact working, I'm going to make a change. So the idea is type a change, submit the change, and it has saved. Now to prove the point, reload the data, and Joseph has now become Joe. Brilliant. Except no things really aren't that brilliant, I'm afraid. I mean, it looks like it works. It looks like it does. I mean, I just managed to save data. So what the hell, Jeff? Why? I mean, I can type anything in here. I can take Susan, for example. Submit that. Done. Reload my data. It works, right? What could possibly go wrong? Well, let's head back into the script and see why. Okay. So I can tell you now that this script here and here is open to SQL injection vulnerability. That's a scary phrase, and I'm sure if you're a beginner, you may have heard of it, you may not have heard of it. Now, some of you have heard of it, and you don't really know the ramifications of what that is, so that's why I replicated it. So I can actually show you what would happen if a naughty person did something naughty. Well, I am that naughty person, and I'm going to do something naughty to my own data. Anyway, just to prove the point to you, what would happen is, in this form here, there is a hidden field. If I go down to the field, you'll see there is an input ID, which is taking the user's ID. Okay, so all I have to do is expose that field, which is here. Just so I can illustrate it to you guys, I'm just going to make it a text field, and I'm just going to put or 1 equals 1, which is logically correct because 1 is always equal to 1. I'm just going to change this to you hacked. Submit. Oh, that has saved. What's just happened? In our database, all of our data has now been hacked. Well, not really hacked. It's been corrupted, and that's not good. And I really wish I had a backup. And the reason this has happened to start with is that I placed too much trust in my users, and I didn't take the default position that they're all just a bunch of malicious bastards. Well, maybe I'm being a little bit harsh. I mean, 99.9% of your users are going to be perfectly genuine, but it only takes that 0.1% to make your life a living hell. So what can we do to protect ourselves against such a threat? If we head back into the script, what we need to do is to ensure that all of the variables we receive from any user data are safe, i.e. we need to validate them. And second of all, we need to make sure that we never, ever supply variables directly in a SQL string, which is then directly executed on the database. So we should always be using parameterized queries. I don't care if the data is coming from user data or data that already exists within your database. We should always use parameterized queries. Okay, so what do parameterized queries actually look like, and how do we build them? How do we use them? So in this script, we're actually using the MySQLi library as an object, so I'm going to roll with it. I personally prefer PDO, but we're going to roll with what this script has. To convert these into parameterized queries, essentially we just need to change these to question marks, which I shall now do. Okay, so make each of these question marks. Excellent. So essentially these act as placeholders, and we're going to supply the parameters that fill these positions. In order to do that, we need to prepare the statement used in the database. So we're going to use db, prepare our SQL string. Right. Now we need to be able to supply the parameters, and we need to do that in the order in which they're specified in the SQL statement. To do that, we need to be able to bind the parameters to our new query. So prepare will return a statement, and so what we'll find is query is now an object where we can bind our parameters. The first argument of bind parameters declares the types of parameters. Now we need to declare that first name is a string, last name is a string, and the ID should be an integer. Now in our type definitions, this would be SSI, indicating string integer. Right. So I'm just going to put the first name variable, last name variable, and ID. With those now set, we can actually tell the query to execute. So we can actually change here to execute with no arguments applied. And if it's successful, it return true, and if it hasn't been successful, it return false. So we'll just assume this is correct. You could actually determine whether something has actually updated if you wanted, but we're not going to worry about that in this example. Through the miracle that is video editing, I have fast forwarded us in time to a place where we now have our original data before it was corrupted. Now, if I go back to our website and I have the fields exposed like I did before I did the hack, and I put 1 equals to 1 again, and I change this back to you hacked, submit. It has saved, but what it hasn't done is it hasn't corrupted all of my data. So the hack is, or the corruption has actually failed because of the parameterized queries have actually kind of sanitized the data that was put in. But we've still technically got an issue. If we head back into the script, we've effectively allowed someone to enter an ID that went unvalidated and was yet still allowed to enter into this SQL query. Although we kind of sanitized it here by saying it should be an integer, we need to be better than that. And to be better, we need to be able to validate that ID coming in from the input. Now, usually my validation, in fact, all of my code is a lot more complicated than this. But for the purposes of this example, we're simply just going to validate that the ID inbound is always numeric. And we're going to add it outside of our if statement because it must always be numeric. So if I put in ID here, and we'll just say echo failed for now. Okay, and I'll exit. And if I go back to our page, which I've prepared, I've already got the data ready. So it's our existing data, or sorry, our original data I've put back. and our web page is ready to rock and roll. Let's press the submit button and see what happens. Failed. Okay, so we've mitigated that issue almost completely with just that one input field. But that's not the end of the story for our ID parameter, because we still need to be able to make our query here a parameterized query, because remember, even though we are validating the ID here, we must always use parameterized queries. So we are going to replicate what we did before. So prepare our statement. We're going to make sure that we are using a parameter placeholder, and we are going to bind just a single integer parameter, which is our ID. Okay, right, in order to get our user data now, we need to execute this query. So we're going to say if not query execute, which you should execute, echo failed, exit, or we will make it so that we can actually get the data, which will be query get result a fetch assoc. Okay, right, so let's just make sure that actually still works. Huzzah! It's still alive and can still save, which is great news, except for the fact it kind of still isn't, because there's still a whole heap of things wrong with this script, including the fact that we've not validating first name or last name, which can result in second order SQL injection vulnerabilities and also cross-site scripting vulnerabilities. And there's just, there's other issues here which, we're all guilty of when we all start out with PHP. But I just wanted to make a series of how to not write PHP. Oh my God, Siri just went off. I said series, not Siri. Okay, shut up. I want to thank everybody who has already Siri, come on man, who's already subscribed. If you haven't already subscribed, please do. I'm very professional, and I'm gonna make this a series, as I said. Just checking, he didn't go off. How not to write PHP. Today was number 1. Don't trust user input. We'll come back to it again. Actually, number 1, because we still need to cover validation. And please subscribe, like the video. Your feedback means the world to me. And I'll see you guys in the next video.